SwayamPrabha. Digital India. Educated India.
Hello students, we once again come back to study critical regionalism in modern Indian architecture, and today we will be looking at part 2. Before I begin this presentation today, or when I start the discussion, I would once again like to thank the people who have been assisting me in this work, because no work is a one-man endeavor or a one-man show. There is an entire team that works with him, assists him, labors with him to build the work. So I have my research scholar Farhan Asim, I have my project associate Shreya Rai, and I have an entire team at E-Learning Center. Sarad is one of those people who are helping me in this work, and of course there is the entire setup of IIT Roorkee which is also assisting and helping us. Why do I say this? This is something like what you would encounter when if and when you go into architectural practice, that it is supposed to be a teamwork where one person coordinates the team, but there is a whole range of people who are a part of that team when they work together. And therefore, I am truly grateful to all these people who are helping me in this work. I know that many times I have tested their patience with my laxness and laziness, but fortunately we have been able to reach to the 29th presentation in this series, or the 29th module today. There is another thing I would like to say. Progress seems to have been slow. Today we will be looking at the buildings somewhere in the 1990s, 80s and 90s. Now there is a reason why that is, and I will tell you why. Firstly, that my endeavor is not to teach you chronologically, my endeavor is to teach you how architecture evolved, and for that I have to focus on certain iconic buildings or case studies that have made a major impact or that are major milestones in modern Indian architecture. The study of this, any one of these buildings, is like a master class in understanding critical response or response to architecture in India with regard to technology, materials, climate, available resources and manpower, and our own traditions and cultural value systems, all of that incorporated in these case studies or these buildings. So what do we learn from these? We learn concepts and principles from these buildings. There will be innumerable number of buildings today in the world of social media, with the boom in digital technology. There are probably hundreds of thousands of buildings that are available on the click of a button. Even many buildings in India, and that is very good, because there are extremely interesting architectural works that are coming up in smaller towns and cities in India that would never have seen the light of day in the print media, because accessing them, reaching them would have been so difficult. But today, because it is so easy that anybody passing by that particular project, any student of architecture, anybody interested in buildings, can take pictures and just simply post them on Facebook or Instagram or any other such medium, and in a matter of maybe minutes or hours, that building has gone to so many wide audience, and over time it is easily accessible to so many of us. Easily putting up digital write-up and blogs concerning buildings by interested students or interested writers is much easier, and disseminating that information is also much easier. That is why there is such a boom. But what gets left behind is the fundamental understanding of what goes behind designing a building that will truly stand the test of time. That is why these buildings not only are a labor of love that I am showing you through these presentations, but they are also buildings from which you can learn how to design. Also, you can learn how to assess modern architecture based on the principles taught in these buildings. Of course, they are not perfect, no building can ever be perfect, but there are a lot of issues that are dealt with in these buildings that you can then study other buildings through them. Therefore, I encourage you to study this in the classroom with me and then go back and look at 21st century Indian buildings by younger architects and younger architectural firms who are working all over India in smaller, even tier 2 and tier 3 cities, and coming up with very interesting and beautiful projects. The other thing is this: whenever, particularly in architecture, a time gap is needed to assess a building or study a building in its totality. It has to run over a certain period of time. People have to have used it, experienced the architecture. Others who are interested should have come with a scholarly or an academic interest and studied the building, and then we start writing about it. So even in the digital period, there is always a lag of maybe of several years before a really scholarly study is done on any particular building. That is why if I were to pick up an immediate building of 2020 and talk about it, I would have very limited information to discuss regarding that building. I would have to rely on some very limited amount of scholarly information, whereas some of these buildings that I am talking about are known internationally. They have been studied very deeply and analyzed with regard to many factors. Like I said, they are not perfect, there are flaws in it, and maybe this is my deficiency, that I am not discussing the flaws of these buildings as much as I should have pointed out some of them. I do try to, wherever I can get to it. And the other thing, of course, is, so this auditing part, this gap is needed in order to truly understand and appreciate a building. So let us again come to the definition of what is critical regionalism, the right balance between the rational approach of modernism clubbed together with the locally rooted architectural tradition of a particular region. This could be any country, it could be Finland, Japan, Brazil, anywhere in South America, anywhere, any part of the world, in our case, our country. So it's a variant of modern architecture. It's not traditional architecture, it's modern architecture in a traditional idiom. It has got greater respect towards the climate, topography, local materials and sociological complexities of a particular place. Like for example, the National Institute of Immunology by Razreval in 1981, or again the French Embassy staff quarters by him in 1967. So 6 things we talk about. We look at history, climate, local materials, ecology, culture and technology or technological sustainability. 6 factors that come together in critical regionalism. We had last time seen the use of traditional materials and methods in the work of UC Jain in the Jodhpur University. We had also seen, for example, the way he has designed the Brise Soleil, for example, in Jodhpur University and the Balotra City Hall, and how that is akin to the modern Brise Soleil of Corbusier, but different because it responds to the climate of Rajasthan. It is built using local materials. He rejected the glass and steel approach, as most critical regional architects have done. Designs are also deeply rooted in the local culture, and modern structural solutions are under a creative design. Again, refer back to the example of Jodhpur University. The 4 lecture theatres have this corridor in between them covered with a pergola, and the pergola, the width of the corridor is defined by the width of the available or the length of the available stone beam. So the stone beams that make up the pergola, their length defines the width of the corridor, and that is, but the organization of the lecture theatres in a step formation is typically a modern way of putting together a lecture theatre. Now there is also focus on both outdoor spaces and terraces, because particularly in composite climate, hot and dry climate and tropical conditions, these spaces are very valuable. So we come to the dictum proposed by Charles Correa. A form follows function was a dictum that was the backbone of modernism. Then Charles Correa gave a dictum for Indian architecture, or modern Indian architecture: form follows climate. That is, form in India plays, climate plays a very important role in the kind of forms we evolve. Now, this may not be fully understandable by your generation, because you come across a whole lot of buildings that have nothing to do with the external climate. They are hermetically sealed glass block buildings, or completely actively controlled buildings with no link to the climate, and therefore these buildings do not have the principle of form follows climate. They are predominantly confined to maybe a functional quality is more important, etc. We will come to that point later. Let us see why this kind of climate responsive architecture developed in India. Our constraint turned out to be our blessing. The problem was that there was a lack of technology or unaffordability with regard to centrally conditioned buildings in India. As a result of that, the architects were constrained to design in accordance with the climatic conditions, and the advantage of that was that there was a focus on the built form. The built form itself had to be climatically responsive. So if I am making in hot and dry in Rajasthan, or I am making in hot and humid in Mumbai, or I am making in composite in Delhi, or making in cold conditions in Kashmir, I have to keep the climate in mind. So therefore, no building based on this would be very region specific. It would be a modern building, built for a modern use and a modern generation, but it will respond to the local climate. That in itself makes it a critical regional building. If I were to remove every other factor involved in critical regionalism, I would remove culture, I would remove every other constraint. This one constraint would be enough to make it a critical regional building, because it is responding to a regional context because of the climate. So the advantage was the focus was on the built form. It had to be an innovative design solution, and the endothermal comfort had to be achieved by the design of the building itself, not by some active control system that we are tending to use today. So the tried and tested lessons of traditional architecture also came in handy. Why? Because each region, the people of that region over centuries have used those ideas in developing their architecture. They did not have the technology of the modern times, conditioning or heating or cooling or any other technology that we use today to condition our buildings. Didn't have that. They didn't have incandescent bulbs even. So lighting had to be taken from day lighting. The lifestyle also was controlled like that. They used to work during the day, they used to sleep when it became night, because it will become completely dark, there is no light. So they sleep early and they wake up with the dawn as soon as it is light, so that they could make maximum benefit of the day. So even the lifestyle was governed by the outdoor climate, by the sunrise and the sunset, right? Today, that's a very simple thing you can understand. Your life is not controlled by that. Your life is controlled by active systems. You have conditioned buildings, you have lighting, so you can work through the night and sleep through the day. It doesn't make a difference to you today. Buildings have behaved in a similar manner. Today our buildings have negated climate, and therefore we need not to focus too much on the traditional design form of a region. We can have, like I had shown you in the last presentation, globally the cities all over the world look alike, so much so that if I were to remove the names on that particular slide where I have shown you different cities, it would be very difficult for you to identify which city is which. So the use of these tried and tested principles that have evolved over centuries in a region were then adopted by these architects in modern architecture, whether it was the Kala Academy in Goa by Charles Correa, or the ICGEB building in New Delhi by Raj Rewal, or the NIFL by Arcom in 2014 in Uttar Pradesh, or Sangat by Doshi in 1918 in Ahmedabad. So the advantage through traditional architecture turned out to be that iconic building forms and aesthetic gave rise to a truly modern Indian architecture. And this was an application of cultural and regional context along with climate. It was evident in the spaces, in the materials. So again you see, for example, the YMCA housing by the design group in 1963, the FTI building by Anant Raje in 1983, British Council, Korea 1992 in Delhi, and one of the very interesting buildings not by an architect but by an artist, Satish Gujral, the Belgian Embassy in 1985. Reason for climate responsive architecture in the 21st century. There are serious, now why am I stating this? I am telling you why we need to go back to this. There has been a period when we have gone to active control buildings, when we have started making buildings that are glass and steel buildings, that are glass and RCC buildings, completely enclosed, having nothing to do with the climate outside. So whether the building was in Mumbai, Bangalore, Delhi or any other place, it was identical, and whether it was in these cities or cities in Europe or the Middle East and America, they are identical. Now coming back to the problem in the 21st century, the whole cycle is coming around. Why? Because we have got a serious global problem of carbon emissions. 38% of carbon emissions are through buildings, 28% through operating the building. Therefore, we need to have energy efficient, low carbon buildings, because we have committed ourselves, our Prime Minister is committed that India will become carbon neutral by 2070. Therefore, buildings have to really pull up the socks, and our architects have to pull up their socks and make the buildings low carbon. The only way to do that is to make them energy efficient. That is one of the biggest ways in which we can, the most significant way in which we can do that. Now therefore, the use of climate responsive architecture, solar passive architecture becomes vitally important. We see that appearing in these 21st century buildings. We see that in the IILM building by Morphogenesis 2013 in Noida. We see that in Sanjay Puri's house, the 18 screens in Lucknow in 2019. We see that in the wall house in Auroville by Anupama Kundu in 2000, and we see that in the Indira Paryavaran Bhavan by CPWD in 2014. So there is a whole coming back to an architecture which is modern but that is also governed by the climate or is climatically responsive. There are also economic benefits by reducing operating energy, obviously, but that is for another time. Now when we design energy efficient or green buildings today, these are the aspects we focus on. Three different types. Number one, they are highly engineered. They are hermetically sealed like a normal actively controlled building, but they are designed in a manner to achieve high energy efficiency within active control. That means the building may not be directly dependent on the outdoor climate, but the building is designed in a manner that it is highly energy efficient with the very systems that it is using. So there is no impact of external climate, but the engineering solution is highly efficient. For example, the Cisco building in Bangalore. Second, use of climate responsive solar passive techniques, totally dependent on that, not on technology, as done by Antonin Raymond, the first modernist building he built, or Corbusier or Doshi or Korea, or this house by Shirish Perry in Kolhapur. Third, hybrid mode, advanced as well as climatically responsive, as done in the IGBC building in Hyderabad by Karan Grover, the first platinum rated green building I believe in the world and definitely in India. And here he has used both. He has used passive techniques, but he has also used active techniques. He has used active methods like PV panels. He has used active methods by using highly energy efficient systems within the building to make it a green building or a bioclimatically sound building, climatically responsive building. Now earlier the techniques being applied were based on observational data. It was based on the data of a traditional architecture of a region. It was empirical data, but now there is accuracy in our prediction of building behavior from the design stage, because we have got the simulation modeling or digital tools and techniques to predict that behavior. And that is why Today, if for example Morphogenesis designs the Jalis of Pearl Academy, which we will study as a case study, they design that with proper solar analysis. It is not some kind of a random hit and trial based on some traditional model, but it is a traditional model adapted to a modern building with a proper sound energy analysis. The building once erected will behave in a certain manner that has already been mathematically predicted. Therefore, we have also got energy efficiency green building codes like LEED, GRIA, energy conservation building code, etc. to design these buildings. Let us come to the case studies of critical regionalism. Just some examples of critical regional buildings. Of course, these are not the ones we will be studying, but like the Young Women's Christian Association building in Dwarka by Morphogenesis 2017, IIM Bangalore by Doshi 1983, Siddhartha Goa by Charles Correa 82, and the Parliament Library by Raj Rival 1981 to 2003. Let us come to the Tube House in Ahmedabad by Charles Correa in 1961 to 62. It is a prototype low income housing, and its shape is to design in such a manner to bring cool air naturally drawn into the building and leaving via vent which is close to the roof, creating a natural convection current and thus modulating the temperature within the building. So, once the air flows in and the hot air rises, moves out through the pergola, which is the back in the courtyard of the tube house, and therefore this kind of a current is created. The hot air rises up and moves out, and cool air moves in again into the building and into the living spaces. And as you see here, there are levels within the overall volume. There is this level here, and then you have a few steps, and there is this arrangement provided at a higher level, and this serves the section in the daytime where the person is, for example, studying, people are sitting and working. Underneath it in a veranda, and there is a courtyard at the back, and this is the living room. Now at night, this entire space arrangement changes. This becomes a sleeping platform, sleeping area. So Korea designs a low cost project by providing multiple use of spaces at the daytime and in the night time. Now this new air from lower level is replaced by fresh air coming in as the hot air rises, as I have told you, the current being created. And now he took the same idea into another project, the Hindustan Lever Pavilion in 1961. It was a random folded RCC plate design structure in gunneted in situ concrete. That means concrete cast on side through kind of a gun mechanism. It's like a gun shoots the concrete. So it is a brutalist building in a folded RCC plate structure. Now within it is encased all these ramps and platforms and multi-leveled spaces. That was very simple in tube house, gets very complex in the Hindustan Lever Pavilion. Now here again, not only is the convection current created, but also it is the multi-level spaces that lead to the generation of the convection current. One of the things that we keep in mind when we want to produce convection currents is to have enough height in the project. So that is why if you look at some of the old buildings, the bungalows during the colonial times, you find them, they've got a lot of height. Even buildings made in the Mughal times, there's enough height because they knew hot air will rise up, it will go up, and the cool air will stay below, and where you have your living space you will have cool air. So that would help in the generation of convection. Now because it is a modern building and levels are important here, therefore the levels within this larger envelope are able to create that height, as in the tube house, so also in the Hindustan Lever Pavilion. Therefore this natural cooling principle functions here also. Now there is also the architectural part of it. Like I told you, the very reason of this climatic, the very fact that there was a climatic response led them to innovative design solutions, led them to explore tradition and culture, and led them to create spaces that were responding to what an modern Indian building would be. The ritualistic pathway is one of those things that Charles Correa repeatedly used in his projects. For example, what is it? It's like the concept of creating a pathway through a museum or an exhibition space which is like an Indian street. That's a metaphor for an Indian street, like the way you would move in an Indian village, or the way you would move in a temple, or the way you would move in a palace. So you find that in the National Crafts Museum, he creates this ritualistic pathway so that you can follow the exhibits as you move along. He did that earlier in 1958 in the Delhi Handloom Pavilion. He does that in multi-levels in a subterranean structure in the Bharat Bhavan in Bhopal in 1975 to 81. He creates this kind of a moving a pathway in Jawahar Kala Kendra. He did that in the village form of the Gandhi Samarak Sangrahalaya as you move through it, and also in the Hindustan Liver Pavilion in 1961. Let's come to the ECIL complex in Hyderabad 1965 to 68. The client was Dr. Vikram Sarabhai. The workspace, which through its form it generates a controlled microclimate. That's what he wanted, that it should generate its own microclimate. And the request was to make the building energy conscious then in the 60s and use solar energy, eliminating the need for air conditioning environment. Therefore, there was also there was a need for incremental expansion through modular units. Now, incrementality has always been an important part of the work of Charles Correa. Now, the solution was a number of modular units that were arranged in a cruciform shape. This is, say for example, one unit. This is that one unit. It's separated to provide natural light and ventilation to the office area. So, there are separate modular units that are put together around, for example, a courtyard, ramps, pathways, and there is an overarching pergola on top of the whole thing. And this is done to create that microclimate. To minimize the heat gain, these three cruciform units were sealed off from the east side. The units were indented into a cruciform to bring more daylight into the workspaces, so that if it was one building, you would get daylight from four sides, and then the interiors would remain void of natural light. But because these are cruciform plans independent of each other, each area is able to get ample amount of diffuse light into the area. On the west there is a panoramic view that they had to capture, and the overall is the shade by the pergola with a substantial overhang towards the west and the south. Now, the roof itself has three ways in which he designed the roof element, or rather there were three elements in it. There was a solid surface, then there is the pergola surface or the pergola roof, and then there is a water reflecting surface that Charles Correa tried out. This was not an experiment that moved on into other buildings. He tried it out in the ECIL building, and there were staggered office spaces that draw air from the east, and then the air moves through this central courtyard space into the cruciform modular units. Now, form follows climate. The importance of the section in a climate responsive design of Charles Correa. Now, if you remember, in the Shodhan House also I discussed the importance of the section. I discussed the importance of the section then with regard to climate, and also discussed the section with regard to the ROM plan of Adolf Loos. Here, you have already seen the section in the Parekh House, where we talked about the winter section and the summer section. Then we see the ECIL building that I just talked about. We will look at the Kanchenjunga building, where again the section is created to respond to the climate of Mumbai, the Gandhi Samarak Sangrahalaya, the Kovalam Beach Resort, and the Ramakrishna House. All of them, the section defines the climatic response of the building. And here is a comparison of how buildings, or rather tall buildings, have undergone a change, and the cycle has, it has come back to the same point. This is Kanchenjunga, climatically responsive building, critical regional building, designed by Charles Correa in Mumbai, somewhere in the 80s. Then come this period in the 21st century. We go tall skyscrapers, this building residential apartments in Mumbai, glass and RCC actively controlled mostly. Of course, there are balconies and all that also, residential block, but intensively what you find is this. Again in this project which is coming up, I think it's a project that is still coming up, I believe in Gurugram or Noida, please forgive me for that. We will be discussing this project. It's morphogenesis work that is coming up, and here as you can find there are a series of terraces throughout the building. This building is very similar. If you want to understand this building more clearly, and we will be studying it as case study, we will try to relate to the Commerce Bank of Norman Foster, but it is also related to the Kanchenjunga building. With the kind of terraces Charles Correa created, they are also creating these terraces. Of course, the materials have changed, there is more use of glass, etc. But the overall form of this building by morphogenesis is totally defined by the climatic response. So, climatic responsive buildings are passive design, conditioned buildings like this are active designs, but we are once again coming back to climate responsiveness, and I am really grateful for that. Now the roof beam that was provided, rather the pergola that is provided, also acts as an ordering device. It lends cohesiveness to the overall design. The level changes take place within it through ramps and pathways as in other projects of Charles Correa, and it continues to remain one of the seminal works of Charles Correa. Now he carried on the same idea in the MRF building in Chennai. I will go a little fast now so you can just quickly wrap it up. Already I am taking quite a lot of time today. 1987 to 92, the design generates monumentality through a single freestanding column, and there is a pergola on top. So this pergola also has a roof garden, and the overall building is protected by the direct radiation of the sun. The terraces gently flow, there are different terraces at every level underneath the pergola, and they flow along with the curve of the road that you see. This curve and these are how the terraces are created, to create a series of terrace gardens which aid in the endothermal comfort. And as you can see, there is a terrace garden at the top also. It is very similar to the contemporary concept of a green roof. Something that we are now defining clearly was coming to them very naturally and organically at the time. These are some of the views of the MRF building. I will take out time just to go through them later. And then because of these projects, Charles Correa developed a kit of parts. That means a kit putting together, and you can come up with a building through that. So leading on from the ECIL Hyderabad, he was able to develop a built form that creates its own microclimate, and this kit of parts contained a section which will facilitate a convection current, an internal zone of microclimate, step terraces and a pergola. And then we find that same kit of parts being used in the Madhya Pradesh State Corporation office building in Bhopal 1980 to 92, and the LIC Jeevan Bharti building in Delhi from 1975 to 86. Variations of the kit of parts in both these buildings, both of them are of the same period in that they reflect a shift in the material configuration in Charles Correa's work. We find the use of glass, we find the use of steel in the pergola, we find the use of sandstone as a cladding material versus plastering before, and of course he was using the RCC frame earlier also. So we find that in both these buildings. Now the pergola itself is a shading device and an ordering device in the works of Charles Correa, and he repeatedly uses that. In fact, it became a kind of an identifying symbol of the projects of Charles Correa. There are many identification points that help you to know that, okay, this building probably could be that of Charles Correa, but one of them is the pergola. So you find that in the Jeevan Bharti building, the MRF headquarters, the LIC center that is in Mauritius, and the Sundaram Finance in Chennai that was done in 2004. It's a huge urban gesture protecting the built form within and creating a sense of a public space in the heart of a crowded city, as in the case of all of them in Connaught Place, and each, this is in Jeevan Bharti building in Delhi, and in each of them. and the pergola is connected, is joined with the pilotis, the freestanding column, and gives it that gravitas, that strength in it. And you find that in say Mauritius, MIRFHQ, ECIL building, Sundram, and here again this is in steel, and then you have an exposed concrete freestanding column in the LIC building. And then in other buildings also, like this building in Goa and other buildings, you find him, this is in the Jawahar Kala Kendra, you again find the pergola with the freestanding column. And of course, there is a pergola in the British consulate building, but not a freestanding column. So we will end here, and we will continue with other case studies in the next presentation. Thank you.